Hey friends, imagine getting EC2 pricing models, on-demand, reserved, spot, savings plans, and dedicated as an interview question. By the end of this video, you'd actually enjoy that. The same EC2 instance can cost you full price, or up to 90% less, and the only difference is a single qualifier word in how you pay for it. By the end of this video, you'll know exactly which word triggers which model across all 5 of Amazon Web Services' EC2 pricing options. In episode 16, we covered what EC2 actually is, the 5 instance families, and how auto-scaling groups keep capacity matched to demand. The instance type tells you what hardware you're getting. Today we answer a different question: how you pay for that hardware, and why the same exact instance can cost wildly different amounts. Most of the terms in this video are intuitive once you see them in context, so we'll define them as they come up, but two get confused constantly, and it's worth pinning them down now. A dedicated host is a physical server reserved for your account, and crucially, you can see the sockets and physical cores. That visibility is what license audits demand. A dedicated instance also runs on hardware isolated to your account, but you get no socket or core visibility, it's tenancy isolation only. Same word in the name, very different use case. Here's how this plays out in the real world. At CodeGorillas last year, a steady-state workload ran 24/7 on regular on-demand pricing for an entire year before anyone caught it. The invoice each month was roughly 3 times what the same workload would have cost on a 3-year commitment. That delta didn't show up as one painful bill, it leaked out quietly, month after month, until the cumulative overspend was large enough that finance asked questions. Nothing about the architecture was wrong, the code was fine. The instance type was fine. The single decision that mattered was how the team paid for the capacity, and that decision was never revisited. Here's the insight that makes every pricing question easier. The right model is decided by workload predictability, not workload size. A tiny unpredictable workload still belongs on demand. A huge predictable workload belongs on savings plans. Once you internalize that, the entire decision tree falls into place. Here's the whole map on one slide. Every EC2 workload feeds into one of 5 pricing models. On demand is the unpredictable lane, full flexibility, no discount. Reserved instances and savings plans are both the steady-state lane. You commit, you save anywhere from up to 66% for a convertible RI or a compute savings plan, up to 72% for a standard RI or EC2 instance savings plan. Spot is the fault-tolerant lane, up to 90% off if your workload can survive interruption. And dedicated is the licensing lane, for software bound to physical hardware. Notice the discount bar at the bottom. The more flexibility you give up, the more discount you get back. That trade-off is the entire game. Think of it like booking a hotel. On demand is walking up to the front desk tonight. You'll get a room, but at the rack rate. A reserved instance is booking the same room, same dates, a year in advance, much cheaper, but if your plans change, you're stuck. A savings plan is a corporate travel contract. We'll spend $50,000 on hotels this year. You get a great rate and you can switch cities, room types, even hotel brands. And Spot is a last-minute discount deal, 90% off, but the hotel can kick you out at 2 in the morning if a paying customer shows up. Before we go deeper, try a quick one. Picture a workload that runs 24/7, completely steady state, but you're genuinely not sure whether you'll still need it in 2 years. Maybe the project gets cancelled, maybe it gets replatformed. Which model would you pick? Hold your answer. By the end of the mechanics section, you'll have everything you need to defend a choice, and the answer is not as obvious as it sounds. On demand is the default. You launch an instance, you pay per second on open source Linux like Amazon Linux or Ubuntu, with a 60-second minimum, and per hour on Windows or commercial Linux distributions like Red Hat Enterprise Linux and SUSE. The moment you terminate the instance, the billing stops. There's no contract, no commitment, no upfront payment. In exchange for that flexibility, you pay the highest hourly rate Amazon Web Services publishes. Every other pricing model is discounted against this baseline. By default, your on-demand instance runs on shared hardware alongside other Amazon Web Services customers' instances on the same physical host. Use on-demand when you genuinely don't know what the workload will look like in a month. Brand new applications, short-lived development environments, traffic spikes on top of a baseline you've already covered another way. The rule is simple. If you can't honestly predict the usage, don't commit to it. Reserved instances are the classic discount model. You commit to a specific EC2 configuration, instance family, size, region, for either 1 year or 3 years. In exchange, Amazon Web Services knocks up to 72% off the on-demand rate for that hardware. Two levers drive the discount size: how long you commit and how much you pay up front. 3 years saves more than 1 year. All upfront saves more than no upfront. Reach for reserved instances over savings plans in 2 specific cases: when you need a guaranteed capacity reservation in a particular availability zone, or when you're committing to RDS, Redshift, or Elasticache, which savings plans don't cover. Reserved instances come in 2 flavors, and the distinction is worth memorizing because distractors love to swap the numbers. A standard RI locks you to the instance attributes you picked and gives the deepest discount, up to 72% off. If you no longer need it, you can sell it on the reserved instance marketplace. A convertible RI lets you change the instance family, operating system, or tenancy during the term, as long as the new configuration is of equal or greater value. That flexibility costs you convertible caps at up to 66% off. The mental shortcut: standard is the non-refundable plane ticket, convertible is the flexible fare. On top of standard versus convertible, you also pick a payment option. All upfront means you pay the entire 1 or 3 year term on day 1, and you get the biggest discount in return. Partial upfront means some money upfront plus a reduced hourly rate spread across the term. No upfront means you pay nothing today and spread the cost evenly month by month, which gives you the smallest of the 3 discounts. The pattern is simple. The more cash Amazon Web Services gets upfront, the more they're willing to discount. Savings plans flip the commitment around. Instead of committing to a specific instance, you commit to spending a fixed number of dollars per hour on compute for 1 or 3 years. Amazon Web Services then automatically applies the discount to any matching usage in your account, up to that hourly amount. Savings plans can save up to 66 to 72% off on demand, depending on which variant you choose, comparable to reserved instances. Amazon Web Services now recommends savings plans as the modern way to commit, because committing to spend is far more flexible than committing to specific hardware. Savings plans come in 2 varieties. A compute savings plan is the most flexible thing Amazon Web Services sells. It covers EC2 across any family, any region, any operating system, any tenancy. It also covers Fargate, and it covers Lambda too. That makes it the only commitment model that touches serverless. The trade-off is that it caps at up to 66% off. An EC2 instance savings plan goes deeper, up to 72%, but you lock to 1 instance family in 1 region. You can still change size and operating system within that family, but you can't hop to a different family. Think gym membership. Compute is the chain-wide pass. EC2 instance is 1 specific location at a lower price per visit. Here's Amazon Web Services' own framing. Straight from the EC2 user guide, they call savings plans the easiest and most flexible way to save money on compute, offering up to 72% off on demand, just like reserved instances. One important nuance: that 72% ceiling applies to the EC2 instance savings plan. The compute variant, which also covers Fargate and Lambda, caps at 66%. Notice the words Amazon Web Services chose, easiest and most flexible. Amazon Web Services is openly nudging customers from reserved instances towards savings plans, and the positioning matters when a question asks which option Amazon Web Services recommends. Now let's put RIS and savings plans head to head, because both still appear in real architectures. Reserved instances commit you to a specific configuration, and standard RIS can be resold on the marketplace if your needs change. Zonal RIS, one scope to a specific availability zone, also reserve capacity, meaning Amazon Web Services guarantees a slot for that instance type. And RIS are still the only commitment model for databases like RDS, Redshift, and Elasticache. Savings plans on the other side commit you to $1 per hour spend. They cannot be sold or modified. A return is technically possible within 7 days of purchase in the same calendar month, but only for plans with an hourly commitment of $100 or less. So for most meaningful commitments, treat them as permanent. They give a discount but no capacity reservation, and the compute version is the only thing that covers Fargate and Lambda. Spot instances are unused EC2 capacity that Amazon Web Services sells at a steep discount, up to 90% off on demand. The catch is that Amazon Web Services can reclaim that capacity at any moment when a paying on-demand customer wants it. When that happens, you get exactly 2 minutes of warning before Amazon Web Services stops or terminates your instance. That warning is delivered 2 ways: as an event bridge event you can route, and as a flag inside the instance metadata service, which well-built Spot workloads poll every few seconds. The EC2 user guide is unambiguous here. A Spot instance interruption notice is a warning issued 2 minutes before Amazon EC2 stops or terminates your Spot instance. 2 minutes, not 5, not 10. That's the window your application has to checkpoint state, drain connections, and shut down cleanly. Here's the mental model that decides every Spot question. Spot is like house sitting for free at a vacation home. The owner can text you anytime saying I'm coming back in 2 minutes, so you keep your toothbrush packed and never leave anything important on the kitchen counter. If your workload can't pack up and leave that fast, if it holds state in memory, if it can't checkpoint, it doesn't belong on Spot. So what actually fits on Spot? Stateless web servers behind a load balancer. When one dies, traffic just shifts. Batch processing jobs, continuous integration runners, anything that can be retried cleanly. Big data and genomics pipelines that write checkpoints back to S3, so a lost worker just resumes from the last saved point. And the textbook example, Netflix-style video transcoding. Each chunk of video is independent, the work is stateless, and if a Spot instance disappears mid-encode, Amazon Web Services just reschedules that chunk somewhere else. A dedicated host is a whole physical EC2 server reserved entirely for your Amazon Web Services account. Unlike regular EC2, you can actually see and target the underlying hardware, the sockets, the cores, the host ID. That visibility is what makes dedicated hosts unique, because it lets you bring your own license for software that's priced per physical socket or per physical core. Windows Server, SQL Server, Oracle SUSE, Red Hat, these licenses are tied to hardware, and a dedicated host is the only way to satisfy that contractually on Amazon Web Services. Amazon Web Services' own one-sentence definition captures it cleanly. Amazon EC2 dedicated host is a physical server fully dedicated for your use, so you can help address corporate compliance requirements. 2 phrases matter here: physical server and compliance requirements. That's the entire reason dedicated hosts exist. Dedicated hosts and dedicated instances sound nearly identical, but they solve different problems. With a dedicated host, you see the sockets, the cores, and the host ID. You get full bring your own license support, and you're billed per host regardless of how many instances you pack onto it. With a dedicated instance, you get single tenant hardware, meaning no other customer shares your physical server, but you have no visibility into that hardware, only limited bring your own license support, and your build per instance. The decision rule is simple. Dedicated instances give isolation. Dedicated hosts give isolation plus the hardware visibility your licensing terms require. That distinction matters on scenario questions that mention bring your own license. And Amazon Web Services itself settles the question in the EC2 user guide. If you require visibility and control over instance placement and more comprehensive bring your own license support, consider using a dedicated host instead. Amazon Web Services is telling you in their own documentation, bring your own license means dedicated hosts. Remember that wording. Before we move into decision rules, lock this one sentence into memory, because it's the single most confused pair in the topic. Savings plans commit you to a dollar amount of compute spend per hour. Reserved instances commit you to a specific instance configuration. Everything else flows from that. Savings plans win on flexibility. You can shift across families and sizes and the discount follows. Reserved instances win when you need a guaranteed capacity reservation, or when you're buying for RDS, Redshift, or Elasticache. Same discount range, very different commitments. Here's the decision tree as 4 mappings. If a scenario uses the word unpredictable or short-term, the answer is on demand. If it says steady state or lowest cost for a long-running workload, the answer is reserved instances or savings plans. If it says fault-tolerant or interruptible or batch, the answer is spot. And if it mentions bring your own license or a socket-based license, the answer is dedicated hosts. The qualifier word on the left almost always determines the answer on the right. These are the exact percentages worth memorizing. Spot tops out at up to 90% off. Standard reserved instances and the EC2 instance savings plan both top out at up to 72%. The compute savings plan and convertible reserved instances both cap at up to 66%. Notice the pattern: 90, 72, 66. The more flexibility you give up, the bigger the number. Locked to specific hardware, you get 72. Trade family lock-in for serverless coverage or keep the ability to swap instance family mid-term, you drop to 66. Accept interruption, you get 90. There's a logic underneath the numbers that makes them easy to remember. The more flexibility you give up, the bigger the discount. Accepting that Amazon Web Services can reclaim your instance on 2 minutes notice, the biggest concession, earns the biggest cut, 90% with Spot. Locking yourself to one specific instance configuration earns 72% on standard reserved instances and the EC2 instance savings plan. Keep the ability to swap across instance families with convertible reserved instances, and the discount drops to 54%. Compute savings plans sit in the middle at 66%, flexible across family and region, but still a dollar commitment. The numbers track the trade-off every time. Here's the why behind the bring your own license rule. Oracle and SQL Server licenses aren't priced per virtual CPU, they're priced per physical socket or per physical core. When the auditor shows up, they need to see the actual hardware your software is running on, so they can count sockets and verify you've licensed enough. Dedicated instances give you tenancy isolation, but no visibility into the underlying hardware, which means you can't prove compliance. Only dedicated hosts expose the physical sockets and cores. So whenever a scenario mentions bring your own license, Windows Server, SQL Server, or Oracle, the answer is dedicated hosts, because that's the only option that survives a license audit. 4 wrong mental models worth correcting. People assume savings plans reserve capacity. They don't. Only zonal reserved instances do. People assume dedicated hosts are a discount model. They aren't. They're a tenancy and licensing option that often costs more, not less. People assume dedicated instances support full bring your own license. They don't. Only dedicated hosts do. And people assume Spot is fine for any low priority workload. It isn't. The workload has to be stateless and checkpointable, not just low priority. Get those 4 right and the rest of the pricing model decisions fall into place. In production, mature teams don't pick one model, they layer all 4. A compute savings plan covers the steady 24/7 baseline that runs every minute of every day. A spot fleet handles the batch jobs, the CI runners, and stateless web workers where interruption is recoverable. On-demand sits as a buffer above the baseline for unpredictable spikes that exceed what's committed, and dedicated hosts only show up where licensing or compliance actually forces them. The discipline is never committing to 100% of usage, you always leave room for the architecture to evolve. 5 things to carry forward. First, pricing model follows workload predictability, not workload size. Second, Spot is up to 90% off with a 2-minute warning, and it's stateless work only. Third, standard reserved instances and the EC2 instance savings plan cap at up to 72%, the compute savings plan caps at 66%, and convertible reserved instances cap at 54%. Fourth, compute savings plans are the only commitment model that covers Lambda and Fargate. And fifth, bring your own license means dedicated hosts, never dedicated instances. Now let's put it to the test with a quick 5-question quiz. Question 1. A company runs a video transcoding pipeline where each job processes a single video chunk independently, checkpoints progress to S3, and can be safely restarted on a different instance if interrupted. Which EC2 pricing model offers the lowest cost for this workload? Is it A, on-demand instances, B, standard reserved instances, C, spot instances, or D, dedicated hosts? Pause here if you want more time. This one is C, spot instances. The keywords are independent, checkpoints, and safely restarted. That's the textbook Spot profile. Stateless, fault-tolerant work that can survive the 2-minute warning. Spot delivers up to 90% off, which is the lowest cost you can get on EC2. Question 2. A company is migrating an on-premises Oracle database to Amazon Web Services. Their existing Oracle license is bound to physical CPU sockets and must be preserved during the migration. Which EC2 option satisfies the licensing requirement? Is it A, dedicated hosts, B, dedicated instances, C, standard reserved instances with the Oracle AMI, or D, EC2 instance savings plan? Lock in your answer before I give it away. The right call here is A, dedicated hosts. The trigger words are bring your own license and socket bound. Only dedicated hosts give you visibility into the physical sockets and cores the license needs. Dedicated instances sound similar but offer only limited bring your own license support. Amazon Web Services' own documentation tells you to use dedicated hosts instead. Question 3. A company has a steady-state compute baseline that runs across EC2, Amazon Web Services Fargate, and Amazon Web Services Lambda. They want a single commitment model that discounts all 3 services with maximum flexibility. Which option should they choose? Is it A, standard reserved instances, B, EC2 instance savings plan, C, convertible reserved instances, or D, compute savings plan? Think about which constraint matters most here. The answer is D, compute savings plan. The mention of Fargate and Lambda alongside EC2 is the giveaway. Compute savings plans are the only commitment model that covers serverless. RIS and EC2 instance savings plans are EC2 only. The trade-off is that compute caps at up to 66% rather than 72%. That's the price of the broader coverage. Question 4. A company committed to a 3-year standard reserved instance for the M5 extra large family. 18 months in, their architecture has evolved and they need to switch to the C6i family for CPU-bound work. Which statement is correct? Is it A, They can convert the standard RI to the C6I family at no charge for the remaining term. B. They cannot change the instance family, but they can sell the standard RI on the reserved instance marketplace. C. They can modify the standard RI to any family in the same region without restrictions. Or D. They must wait for the 7-day refund window to reopen before making changes. Got your pick? Let's see. It has to be B, and here's why. Standard RIs lock the instance attributes. That's the trade-off for the deeper 72% discount. To change family midterm, you would have needed a convertible RI. The escape hatch for standard RIs is the reserved instance marketplace, where you can sell the commitment to another customer if you no longer need it. Question 5. A media company runs a nightly batch transcoding job that takes 4 hours and can be safely interrupted and resumed. They want the lowest possible cost. Which EC2 pricing model is the best fit? Is it A, a 3-year all upfront standard reserved instance for the transcoding fleet? B, on-demand instances so the job always finishes on time? C, a compute savings plan with a 1-year commitment sized to the nightly peak? Or D, spot instances with checkpointing so the job can resume after an interruption? Lock in your answer before I give it away. The right call here is D. 2 queues point straight at spot, the workload is interruptible, and the goal is the lowest possible cost. Spot gives you up to 90% off on demand, and with checkpointing, a 2-minute reclaim notice just means the job picks up where it left off. Reserved instances and savings plans would lock you into capacity that sits idle most of the day, and on-demand is the most expensive option on the list. And that completes EC2 pricing models: on-demand, reserved, spot, savings plans, and dedicated. One topic at a time, you're building real expertise here. Proud of you. See you in the next one.